Welcome to today's lecture. Today we are going to continue from where we had left in the previous lecture. Today we are going to discuss the problem of vibration isolation. So basically we'll discuss what techniques are suitable for this purpose related to machine foundations. Sometimes the machine vibrations, they are found to be excessive after installation and when the machine starts operating. Now these were not anticipated at the time of the design. The design was, let's say, done in accordance with the inputs from the manufacturer, in accordance with the geotechnical parameters as per the soil investigation report, and all the provisions of IS 2974 were followed. But still the users, they are reporting such disturbing vibrations. So then vibration isolation measures are necessary. The purpose is to reduce or suppress the unwanted or excessive vibrations so that they are brought to the acceptable level. So the vibration isolation which we are talking today, basically these are referred to post construction. So in this lecture we are basically talking about the remedial measures which can be applied post construction and the beginning of the operation of the machine. Now let's say, what are the causes when everything has been done as per the design? There could be multiple causes. Number one, there could be insufficient or erroneous design data, either inputs from the manufacturer or the geotechnical parameters. Many parameters associated with soil are a subject of statistical variation and uncertainty. Other possible reason could be introduction of wear and tear in the machine. Now it is a common observation that older machines, they generate higher level of vibrations. Or there could be any other unanticipated reason not considered during the design. The first type of remedial measure is to counteract the vibrations at the source itself. If at any time during the operation of the machine sudden abrupt vibrations are noticed, then we must consult the manufacturer or the expert we must get the machine itself checked for any wear and tear. Now this wear and tear could be in various components. It could be in the bearings or any other moving parts. Or it could be loosening of the tension in the belts, such as in the case of the older type of compressors associated with the air conditioning of the buildings. Or clogged filters, again a problem associated with the air handling units of buildings. So it's very important that the machine which is operating should be regularly serviced by the machine should be regularly serviced by the manufacturer or his authorized representatives. And yes, there is something also possible, counterbalancing. We have already studied what it means. However, in the operational stage, it is possible or not, that's a question mark and depends on the manufacturer. The earlier remedial measure was related to the machine. Now we will study the remedial measures which can be applied to the foundation system in case remedial measures with the machine are not bearing any fruit. That means the problem does not lie in the machine but in the foundation. One such method is soil stabilization, which can be applied post construction. Essentially, it means that we increase the stiffness of the soil underlying the foundation system. So let's say we have the foundation system already constructed with the machine sitting at the top and operating. What this step involves is excavation of the soil all around and reinforcing it in various pockets. So we need to do excavation all around the foundation. And then we make pockets one by one all around the foundation. So we begin with the corners, and these pockets, they are grouted. So like this, we just choose a corner of the footing and we do grouting in the soil underneath. So this reinforces the soil and increases the stiffness of the system. So it's shown in the plan like this, that we begin with the 4 corners. Now we have to do the process such that the foundation, its alignment is not disturbed. So it must be done in a symmetrical manner. So if all the 4 corners are covered, then we can increase the number of pockets in the other regions like shown here. So these regions which are new in the next phase, they are basically the regions near the center of the edge. Now the question is that, is this measure helpful always? Now what this measure does is it increases the stiffness, so it increases the natural frequency of the foundation machine system, so as a result of which the R, that is the frequency ratio, would go down. We are drawing a plot of the amplification factor versus the frequency ratio. Here we have a critical point at the frequency ratio R equal to 1. So if our frequency ratio is greater than 1, that is we are lying on the right side of the resonance peak, then this measure would be counterproductive because it would increase the amplification factor due to reduction in R. However, if we are on the left side, that is R is less than 1, then it will be helpful because it would bring down the amplification factor. So we must avoid this measure when R is greater than 1. The next remedial measure we are going to discuss involves increase in the area of the foundation. So it's also associated with the foundation. Now here, when we talk of increasing the area of the foundation, we are meaning increase the area of the base portion of the foundation only and not the entire block. Otherwise, this would increase the mass also in the same proportion. So let's say we have a foundation block system where we have a pedestal block and then a foundation base. So what this measure involves is increase of specifically the dimensions, the planned dimensions of the base which is in contact with the soil, so that stiffness is increased. So there would be already existing reinforcement in the base. So what this process involves is that we need to excavate the soil surrounding the foundation, as in the case of the previous measure, and then we need to chip off the concrete cover from the base so that the reinforcement is visible. New reinforcement bars of the proposed extension of the base slab, they are to be welded to the existing reinforcement, and then once this has been done, casting of the extension of the base slab can be done as is shown here. It should be noted that the plain concrete layer, which is usually provided below the foundation slab also needs to be extended. It's important that the process is applied symmetrically around the foundation, and care must also be taken that alignment of the foundation system is not disturbed while the construction is taking place. Now this process increases the mass of the foundation system also, but because the extension has been applied to the base slab only, the proportion of increase in stiffness is much higher as compared to the proportional increase in mass. Another point to be noted is that this measure is helpful only in the situations when the frequency ratio is less than 1. The next remedial measure which we are going to discuss is the attachment of an additional slab near the top of the foundation. As by now it must be clear, this also involves increase in stiffness, so this measure is also helpful when R is less than 1 and therefore not recommended for cases where the frequency ratio exceeds 1. As compared to the previous two measures, that is soil stabilization and increase in the area of the base of the foundation, this measure does not require excavation to the full depth of the foundation. It only requires excavation near the top pedestal, and as such it poses less danger to disturbing the alignment of the foundation system. So here we are showing the foundation block and the pedestal. The reinforcement in the pedestal is marked here. So this procedure basically requires excavation till the pedestal level and fixing new reinforcement for the new slab, and for this purpose preferably the reinforcement must pass through the pedestal. In case of very large pedestals, the reinforcement must penetrate to the minimum development length and should be welded to the existing reinforcement. After this step, then the new slab can be cast all around the pedestal.
हेलो, मैं गोपिका, आपकी प्रोफेसर गोपिका बोल रही हूँ। बोलो, मैं डॉक्टर गोपिका बोल रही हूँ। बोलो, बोलो, नहीं बोलना। अच्छा चलो, मेरे हेठा।
The construction process is shown in plan here. The next remedial measure which we are talking is increase in mass of the foundation block. So as we have already studied, this is effective for the case when the frequency ratio is greater than 1, because this process basically reduces the natural frequency of the soil foundation system. So it increases the value of the frequency ratio R. So let's consider a foundation system where we have pedestal and the base slab, and this is supporting the machine at the top as shown here. The process involves increasing the thickness of the base slab rather than increasing its area. Since thickness is increased and area is not increased, so it leads to increase in the mass without increasing the stiffness. So the process is explained here. So new reinforcement is laid. It preferably passes through the pedestal and in any case needs to be welded to the previous reinforcement if it's not passing all through the pedestal, and then new concrete is cast. The steps are written here. We need to chip off the concrete cover, lay the reinforcement, and then cast new concrete. So thank you very much. If you have any questions, you can discuss them during our interaction in the MST.